First of all, thanks for being here. Alex is today not here, he catch COVID. So normally I'm just a co-speaker, so that was Alex's main talk. But I will try to do my best to get the talk done and also try to answer the questions later on. So yeah, today we talk about firmware bleed. Probably you know red bleed, or you've probably heard of it, speculative execution attacks on processors. And we will talk about the failures to adopt the mitigations of it inside the firmware. And this has a really big impact. But first of all, yeah, who we are. Basically, I'm Philipp Deppenwiese. You probably know I'm also the founder of the OSFC. I'm also a security expert and developer and architect, and Alex is more as a security researcher. We did a lot of open source projects. As you can see, I'm working in Core Boot and Linux Boot. Alex did a lot of IFI Explorer, firmware hunt, and whatever. So he has let's say 20 years or more experience in IT security, and he also contributed to a lot of open source projects. So first of all, we do a recap of the firmware supply chain. So you probably know the firmware supply chain looks really complicated. So that's an easy view on the firmware supply chain. So if you're building firmware, or let's say if you're shipping a product like Dell, Lenovo, HPE, you need to have like vendors developing firmware for you and packaging it. So, and it starts with a reference implementation from the SOC vendors. So for example, Intel and AMD, and they use sometimes also open source technology like Tiano Core, and they have some reference implementation they package in. And then this code and software is used by independent BIOS vendors. You know, probably the most famous one is AMI and Insight and Phoenix. Some companies like Nylon and Cybersecurity doing that as open source, as example. Yeah, and they also package code and stuff in there, so there's more code incoming. And then there are also code from device manufacturers who are more doing the hardware stuff, but they're also provisioning the hardware. So the software relies heavily on provisioning hardware components in the factory, and also sometimes a bit additional code in it. And so everything from them goes then into the OEM product. You have probably on your here with you as well, the laptops and the desktop computers, whatever. So everything is in there, and there are multiple people adding code in there. And this is a big problem because you not only have one supplier, you have multiple suppliers. It's a chain. It's more like a tree of suppliers supplying software, and the software can contain vulnerabilities. So it means in the end, it can be one vulnerability from the component supplier for the hardware security module as well, like the TPM. That's one option. That's the reason why probably Google goes for OpenTitan with their own implementation and having more transparency there. Then you can have from a component supplier, for example, from AMI, which adds a module or whatever, also zero-day vulnerability. You don't know where it's come from. And there are multiple other vulnerabilities. And in the end, for the end customers, it all arrives. So the OEMs, most of the time, they can check all these components, and they don't have tooling yet. It's still starting. You probably heard of SBOM from the US, more like getting more transparency into firmware layer, so software bill of materials. And so they're trying to get into that direction, but it's still not the case. So there are a lot of vulnerabilities in firmware. So how does that look really in the real world? So I just explained a little bit of theory, right? So this was like from AMI firmware, and they have multiple vulnerabilities found in the firmware, and they were used in different kinds of firmware multiple times. So you could have that in Star Labs, in Lenovo, Dell, Fujitsu, and Intel platforms. And that was a big issue. And these came out, for example, a few weeks ago. You can find that in the internet. And this is what Binary and Alex teams as researchers found. After 1 month, they just said these are so many, let's say, vulnerabilities they found after just 1 month of research. That's a lot, right? And they are all high vulnerabilities. So they are not like low. They can be used for arbitrary code execution inside firmware and SMM and other components. So this is a real big issue. In 1 year, until now, they found 60 plus, I guess, vulnerabilities, high vulnerabilities. That's a lot. And they are just one company or team, as you can think of it. Yeah. So how we can make better? So the US, so President Biden signed a few days ago, like let's say some memorandum about that for critical software or infrastructure, these components need to be additionally documented. So that means we need more transparency as part of the SBOM. This is a software bill of materials, like a list of all software components inside your hardware. but also the firmware itself is single point of failure, and it's for the endpoint customer device, it's hard to validate. Even if HPE, Dell, and Lenovo validate stuff, they can't make sure that nothing so that there are no vulnerabilities in the end customer devices. And there can be also sometimes things they slip through their hands, and so you will see later that this is also really the case. Yeah, so what is firmware bleed? So as you can see, is a link. You can also later look. We will make the slides public. Firmware bleed in general is like similar to red bleed for the operating system. So you try to exploit, let's say, through speculative execution. You can, let's say, find more information in the internet, but it's about the return stack buffer stuffing logic. So you try basically to protect against let's say, information leakage inside the components, yeah, by exploiting parts of the branch prediction in the processor and so on. And so in this case, with firmware bleed, it's about the SMM. So the SMM is the runtime component inside the hardware, and the SMM is running all the time. And that means you can also have like the same attack for the kernel and operating system, like in the firmware level. And this is a big problem because often you have those RSB entries to protect against those, let's say, those Spectre attacks. But the thing is, it was also introduced in 2018 in August. But the problem is it's not covering everything. So the resume from SMM and the SMM entry function is not covered on the most of the system. So they're basically vulnerable. And you can see that. So they first thought there's no case of that, but it looks like, so Intel brought out the CVE few weeks ago or a month ago, which is also covering this issue. And they are quite ineffective with this ARSB stuffing. So ARSB stuffing is good, but if it's not completely covering every part of the firmware component, especially the SMM, it's basically not enough to cover the entire firmware level. And so the impact on the industry can be basically disclosing information in the SMM memory, for example, credentials, whatever. It depends on what runs in the SMM. Sometimes there's more features in it, or more technology or security technology, which relies on those credentials. Another issue is that you can do arbitrary code execution. That means you can just launch something inside SMM, which makes you the ultimate power to do whatever you want, because SMM is quite high level over the hypervisor and operating system. So that's probably for cloud environments even a greater impact if you think of people sharing multiple systems. And so Spectre attacks always are about to attack the processor, and you can basically get information from multiple people using the system, what's in there and so on. So it's really bad, and you can stop that by using hypervisors. So that's really a big problem for the cloud. Yeah, as you can see here, this is a normal case. So I'm not the expert for assembly, I have to say. This is normally Alex part, but the thing is you basically add those traps everywhere for the Spectre attack. But the problem is in this case, it was on two places where it should have been in 3. And so one is missing, and that's a resume from SMM in the SM entry function. And so this is like a big problem that it's still, I mean, this is like probably not bad that they already have this there, but also it has a performance impact. Red bleed has a performance impact on the kernel, but in the SMM, it's because of real-time opportunity you have with SMM, or no, not real-time opportunity, sorry. If you want to use SMM, it's kind of slow already. And it's interrupt-based. So, and if you have like this protections in it, it gets even more slower. And if you have also the UEFI DXE dependency tree you have in the UEFI, there's like a dependency tree in the firmware, it gets even slower. That means you can't use those mitigations. Even if you build them in, they're unusable. But so it's complicated and a big issue. And so this looks like, so if there's no mitigation at all, it looks like this, basically. And there are also alternate code, let's say different code, code patterns they found basically inside firmware images. This is what they research. They do a lot of reverse engineering, and so they figure that out. Yeah, most of the system does not have any FFV mitigations because of performance impact. That's one thing, or probably also because they forgot to add it. And other systems, they have it, but the code flow exposed, yeah, in the operating system, it doesn't protect. So it means like the resume is not covered, it is not covered, whatever. So that's not a good thing. And so how do we detect basically firmware bleed, right? So how do we can detect it? So they write open source tooling. So they have like FVHunt is like a rule set, which maps then later for the reverse engineering tooling, which is also open source they wrote. So you can define like vulnerabilities, implants, or also mitigation failures with this kind of rule set and this language they wrote for it. And then you can define it and you can use it to detect vulnerabilities in binary images, which is really nice. And this is what FirmwareHunt is about. And there's a FirmwareHunt scan tool, which is also available open source you can use. And you can just use your firmware image, use a rule set. There are more rules. It's not only one, like there are multiple vulnerabilities and so on. And you can check then for this, in this case, for firmware bleed vulnerability on your firmware image. And it will just scan the binary image in the end. It's also integrated in LVFS. So there's an LVFS integration. So LVFS started to work together with Binary, and they made the FirmwareHunt available. So you can check that if you're using LVFS and see if your firmware is containing a vulnerability. Yeah, what do we get out of it? So first of all, a lot of firmware is still unpatched, or the mitigation doesn't work out. That means nearly all systems you will see are completely vulnerable. So they found a lot of firmwares which are vulnerable to that attack. A lot of systems are still unpatched. Same goes for, there's like HP, Lenovo, I can just name some, but you can also later, I can show you, that's like more interesting. They have like a list, completely full list on GitHub publicly. You can check where all systems are listed. And you can see it's like they're ignoring the problem, and it's also hard for them to fix it because of a performance impact. But it's a real big issue because if you can use that to exploit or run arbitrary code in SMM, you can put implants in there. If you put the ransomware inside, let's say inside the SMM and into the flash memory, then you have a big problem because you basically not getting it out of it, right? And you probably can't detect it, and so it's hell. Yeah. And that's basically the thing. So you can say you could also do code analysis before you bring out the firmware, right? But the problem is the code analysis never shows the complete thing because of the supply chain. So they're adding binary modules to it, to the firmware components. And so they get not every open source component, even if they get, sometimes with the compiler things happening. So it's at the end, you should scan the firmware image as a binary and not on the source code level. So this is like, you need to really check that later also on runtime, because they already experienced with, even with some of their customers, that they told the customers, here's a vulnerability you have, and they could say, yeah, great, we fix it. But then in the end, it still appeared at the customer's end. So that's not a good sign. And so it would be good to have a validation through the operating system. We are currently also working on getting firmware exposed to the operating system so that you can download the firmware image of an x86 system in a standard Linux. Under Windows, it's like you need drivers, but in Linux, it should be soon integrated into Linux kernel. That means we can finally get out those firmware images, and you can really test it on the user space and look what's going on there. So that's quite important. Yeah, and so if you want to test it out yourself with your hardware, what you have, or your firmware image, and you can get it somewhere, or you just download it as an update and put it in, you can just use their FirmwareHunt Run. It's like a free software they provide, and you can just upload it and see what kind of vulnerabilities or mitigation failures your firmware contains. And that's kind of great, because then you get at least some kind of transparency what's going on and what you have on your system. Yeah, thank you. Any questions? Yeah.
Is there a proof of concept for the actual attack?
For what?
For the actual attack, like you mentioned code.
So you mean like someone used it to basically get into the system. Not yet, I guess, but you have to ask Alex. I'm not the expert in that area, so I'm sorry.
Yeah, I will.
Yeah, but you can just ping him, so he's available, and I mean, probably know him personally. So
it will be difficult to convince like anybody from the BIOS vendors or OEMs to do anything about this vulnerability if there is no way to show them that the vulnerability is actually, impactful. And by that, you need a proof of concept or just GTFO.
Yeah.
So that's mostly why.
That's correct. Probably they have a proof of concept implementation. But the thing is, I mean, you can also just wait until some point, more where like the guys, where attackers will somehow build something, right? So I mean, if you make those vulnerabilities public and they don't get fixed, in the end, someone will use it. I mean, it probably takes a few years, but that's how it goes. But it's really a shame that we in the firmware level it's a level that you really don't try to fix vulnerabilities. I mean, zero vulnerabilities in other software is directly updated and fixed and tried whatever. But in the firmware level, it's like we always discussing if it's really worse and whatever. So it's like it's not like normal software development. I think this is a bad idea. But you're right. So I will ask, or you can also ask him if you want. I can do that. Yeah, that's good.
Hi, thanks for the talk. I have a two-part question. The first one is about the firmware hunt scan utility that you provide. What the kind of technology it uses? Because in some of our tests, it looked like it's like looks for patterns of existing attack that you found in the wild, but it's not generic, as in doing some static analysis, trying to decompile and then really understand what's going on. So it cannot find similar attacks based on the same mechanism, but on firmware that you wouldn't have had in your set of problematic firmwares. And if that's the case, then about your conclusion that we need more validation at the binary level, either we need completely different technologies, much more advanced, to do static analysis at the binary level if we really want to rule out that kind of attacks on new firmwares, on new versions, not only on unpatched old firmwares. But maybe the solution is also to push more for open source firmwares where we can do source level analysis, static analysis, which is much more powerful.
Yeah, so source level analysis is not much more powerful because you have a compiler and compiles it, so you can try to figure out if everything went well, but you don't know if the translation from source code to binary is really containing the thing you want, right? So, and also in the firmware world, you can say everything open source is probably a good idea. It moves into the right direction, and it probably solves some parts of the problem, but try to convince the supply chain, right? So, and I think it's the moment it's nearly impossible to do that. So it will not the case in the next 10 years or 20 years. Probably we will, I hope so. That's why I founded the conference, right? And trying to go into that direction. But it's really hard to convince vendors to be completely open source. Even if they open up partly for like core boot or the Tiano core, you can use your still binary components in it. And that makes it really, really hard to figure out if there are no vulnerabilities in it. About the scanner, I can't tell you so much because I'm not the guy who developed it, basically. That was Alex. But as I know, you're right, they're working with patterns, but they have some kind of special automatic reverse engineering technology where they can match the pattern to the vulnerability. And for sure, you have to define what kind of pattern it is to detect the vulnerability. But so just in theory, everyone can do that. So you can use that also to find other vulnerabilities in it. So it's not like specialized on just one vulnerability and one device and so on. So it's used to validate a lot of binaries, and you can detect the vulnerabilities in it. Just defining them. But you need to ask him. It's sorry for that I can't answer the question.
No worries. I will also ask when he's available later, because it really looks more like it's automating a team of reverse engineers, but you still need this expertise of the reverse engineers and then to apply it in more places.
Yeah, but that's the case, right? How we currently work. The whole lot of reverse engineering guys and trying to figure out 0 days, and then I mean they're probably not looking so much at the code.
Yeah. I have a formal method background, so I'm probably biased in trying to prove things correct as opposed to.
Okay.
selling results, the results are open,
Yeah.
and you can run the results against the firmware. But the actual technology to obtain the things, to find the vulnerabilities in the first place, is proprietary to the vendor. So this solution that the cloud thing you want to buy, not fully open source for everybody. And the open source part is just, here are the patterns. If you find them in your firmware, you are probably
Yeah.
have vulnerabilities.
Yep, that's correct. So basically, this is a community, or this was a community version of Binary, which with some pattern matching, and the cloud version is more powerful and like commercial product, right? So you can use it as technology to detect that. And there are also multiple other companies currently looking at it, but yeah, I didn't want to talk too much about the product because we are like more open source guys here and trying to make more open source, talk about open source opportunities, because it's also, the community scanner is also integrated into LVFS. And so they get the benefit out of the binary research they do and also from other vulnerabilities they find and malware. Yeah. Yeah.
I saw in your presentation that you named some companies, are mostly OEMs, but it seems that you are more likely oriented on the customer products rather than on the server product line.
So also server. So on my server, we have a server Lenovo SR630 version 2, which is a new one. It has the FirmwareBleed vulnerability, and so you can do arbitrary code execution properly on the system. It depends on what kind of technology is in there, but this has a vulnerability in it. Yeah, we figured out. So it's on the client or the server side, it's regardless. So all x86 system or IoT, yeah.
I was wondering because you spoke about the broken supply chain, but they don't have the same supply chain between the consumer lines and the server lines. They don't.
It's probably this is right. Sometimes it's probably different, and some vendors also improving, but some are not doing that. So I would say server products are more matured, and so they might have less vulnerabilities, but they still found vulnerabilities in HPE systems, and that was basically in the news a few days ago, and so. That's still the case for server systems as well as for client systems. I guess server systems are more robust, but they also contain more code. So you can say, however, if that's more secure or not, I can't tell you. But yeah, did I answer your question or did I get it wrong? Okay.
Hi.
Yep.
RSP stuffing is included by default in all of the images. I just compiled one now, and it's there. I guess the question is, how do we get vendors to actually pull that into their tree?
This is correct. This is also what I said. So since August 2018, right? So, but the thing is, from let's say the resume from SMM is not covered as far as we know. Or probably there's some stuff missing. So you should contact Alex and ask him. That's one problem. The other one was that that basically the vendor's not adopting it because of performance issues and probably because they don't know what impact it has. You're right. So that's, I would say, the biggest problem at the moment, that they're even not trying to enable those patches. Yeah. Do you have any insight? Are you a UEFI engineer or?
I've ported min platform to an old laptop that I had, so
okay, cool.
I can compile for that. I looked in those images. If I'm reading the disassembly correctly and the git blame, it should be unconditionally included for all platforms as of 2018.
Yeah, that's correct, but they're not enabled for the vendors.
Maybe it's the vendor trees.
Yeah, I think that's, as I said, the supply chain is quite big, even for server platforms. They might work more on their own, like HPE, Dell, and Lenovo, and do their own stuff, but they're still getting in things from the outside. I'm quite sure.
That could be it.
But you can probably also ask people from HPE here. So John Marie is here, so I don't know. I'm not the expert here in that area. Any other questions? Oh, yeah.
Actually, just a simple question out of my curiosity. Is this applicable to ARM or just applicable to x86 systems?
Oh, that's a good question. I think you can also apply that to ARM without any issues, right? It's just a binary. So the technology part, definitely. I don't know if they integrated it completely or they're more focusing on x86. I would need to ask them, but you can also just ask around. So Alex is also in the open source firmware channel. So if anyone is there, you can also directly contact him and just ask some questions
Okay.
afterwards. So he will help you out. He told me that.
Okay, thank you.
No problem. Yeah. Any questions left? I can also later.
Okay, then thank you, Philip, again.